In the previous video, we have started implementing MapBrain script and implemented some core functionality, but now we need to discuss a matter of how are we going to choose parents for a recombination of our maps so we can achieve a better output. So we are going to talk about roulette wheel selection. So let's look at the slides. To select a parent for reproduction, we want to choose the best performing parent there is. But to achieve variety, we don't want to only choose the best one constantly, because then there is a chance we are going to fall into a local optimum of the output of our function. This fitness proportional selection function will allow us to choose randomly, yet give the parents that have the best fitness the biggest chance of being selected. We are collecting the total fitness of current population, so then we can choose a random value between 0 and maximum fitness score of whole population and say, okay, if this is in range of the candidate A, then this candidate A will be selected as the parent for reproduction. But at the same time, we can select by a chance the lowest active performing candidate, so with the lowest fitness. It has still chance of being selected for a recombination of the obstacles between the map of one parent and another to produce a children candidate maps that will be used in the next generation. So this way we can achieve the optimal result from our function. Let's go back to MapBrain script. Okay, let's slide down and search for our roulette wheel selection function. Here it is. So delete the throw exception code, and what we are going to do is, first of all, choose a random value equals random dot range, and we need to slide up and say using random equals Unity engine dot random to avoid the collision between system random and Unity engine random. So let's slide down and random.range, and here we are going to choose from 0 to total fitness of this generation, the variable that we have implemented beforehand. So now we have the score that is in range of one of the solutions that we have. So what we are going to do now is loop for I equals 0, I less than population size, and we are going to choose random value, and we are going to subtract for it calculate fitness by choosing the current generation with index I and returning its map data. So we are going to use our function calculate fitness that we will soon implement to calculate the fitness of our solution. And now we are going to subtract this value from random value. And if our random value was within the range of the fitness of this solution, this value will become less or equal to 0. So we are going to check if random value is less or equal to 0. We are going to return the index I. So this candidate map will be taken as the parent. And if this is not the case, and we have run out of candidates, we are going to select the last candidate, so population size -1. Okay, great. We need to implement the fitness, calculate fitness method to get the score for this roulette wheel selection. So what we want to do here in this method, we are going to calculate how good is our map. And as I said previously, we want to choose a map that has a long path, multiple obstacles, not so many corners, and not many corners that are near each other. So to implement all of those, we first need to calculate int number of obstacles equals map data, because we are getting this obstacles array, and we are going to use link library, so where and Alt-Enter using system.link, and we are going to say is obstacle is lambda expression is obstacle. So if this value is true, and at the end we are going to say count. So this is the number of obstacles that we have in our map, on our map currently placed. Next we are going to create int score, which is our fitness score, is equal to data map data dot path dot count, so the length of our road, which is the main factor depending on the weight that we set for it, times fitness the path weight. So we are going to multiply it by the weight, so we might decrease the weight of this parameter for our score. Next we are going to add to it our int, our number of obstacles that we have previously calculated, times the fitness obstacle weight. So this gives us some kind of score for the path length and the number of obstacles. Now we need to calculate how many corners do we have, so count corners count equals data map data dot path, and we have corners list, I think, dot count. Okay, so now we are going to check if our corners count is greater or equal to fitness corner min, and our corners count is less or equal to fitness corner max. If it is so, we are going to add to our score plus equals corners count times our fitness corners weight. So this will indicate that the more corners we have, the more scores, the more we add to our score. So we prefer a path that has more rather than less corners. Else, if our corners count is greater than corners count, fitness corner max, we are going to subtract score minus equal fitness corner weight times, and we are going to subtract a corners count minus fitness corner max. So we are going to subtract the amount of corners we have extra above the max value times the corners weight, and else if our corners count is less than fitness corners min, we are going to do exactly the same, but instead of subtracting, we are going to multiply it times fitness corner min. Now again, calculating the fitness or finding the cost function isn't that easy, so I have implemented it like this, but I'm certain it can be improved to give a even better score for your maps. So basically what we want now to do is to return our score. So this is the score we have calculated for our map, and basically it will tell the algorithm how good is our map and should it be chosen for the next generation based on the roulette wheel selection decision or not. Okay, great. So in the next video we are going to take care of this crossover parents function.